JMath.
In this video, we will be looking at grade 12 identities. Now, if you remember from last year, it wasn't too bad. You only had this bottom block to remember. Tan is sine over cos, and then cos squared plus sine squared is equal to 1, so only the blue ones. But now in grade 12, they add the double identities and also the compound identities, as you can see. So just consider all of them when doing this. So many people don't like identities, but give it a go. They tell you at least where you need to head towards. So maybe you get a nice one in your exam. Don't just give up and not even attempt this. You can pause the screen here and just jot down all the notes. Identity is one of the more difficult ones because each one works a bit differently. But if you remember these bullet points, some of them will definitely help you and get you to the answer closer. But let's do a few examples and then see how we will get there. So question 1, let's start off with the easier one. We can see immediately there are double angles there. Okay, so there's a cos double angle. So I don't know which one will help me get to the answer, but the bottom one only has one option. So I need to tell them I'm working with the left-hand side. Now remember the note up there, you always choose the side that looks the most complicated and try and work with that. So I know the right-hand side is going to be sine over cos. So I want sine values up top, and if I can, cos values at the bottom. Okay, so at the top, 1 minus. Now, which double angle for cos will help me get a sine on top? So I don't want cos on top, so only one option does not have cos. So that would be bracket 1 minus 2 sine squared a. The bottom, I'm definitely going to change because the right-hand side does not have a double angle. So that's 2 sine a cos a. Okay, so up top, I'm going to multiply the minus in, and that gives me 1 minus 1. So it's just going to go away. And then that leaves me with 2 sine squared a. At the bottom, 2 sine a cos a. And great, now the 2's can cancel. The bottom sine a can cancel the squared. And just have a look at it. I have sine over cos, which gives me tan of a. And remember to always end off with left-hand side equals right-hand side. Perfect. You proved this identity. The next example. Okay, so I need to choose the side that looks the most complicated. So let's start with the left-hand side. Left-hand side. Okay, I'm immediately going to change the tan, and then I can see the right-hand side does not have a double angle, so I can change the sine double angle as well. So I'm going to say this is sine a over cos a multiplied by 2 sine a times cos a. All of that is still over 1. This was a massive fraction, so at the bottom I still have 1 minus cos a. Okay, perfect. So now I can cancel a little bit, and there's a cos a, there's a cos a. So the top simplifies to 2 sine squared a. The bottom, I can not do anything, so I'm just going to leave it like that. Okay, so now my grade 11 identity says sine squared. I can rewrite as 1 minus cos squared a. Okay, still looks very close to the bottom, but because of that square, I'm not allowed to cancel out. But up top, one of the notes said I can now do factorization. So the top is actually difference of squares. So I'm going to say this is 1 minus cos a and 1 plus cos a. And the bottom has one of those brackets. So 1 minus cos of a, and that can cancel out. And then if I multiply this 2 in, I'm going to have 2 plus 2 cos of a. Perfect. And then left-hand side equals right-hand side. Okay, so we immediately changed tan. Then we changed the double angle because the other side did not have a 2a. Then we simplified, and I then needed to consider, okay, but that sine squared, I needed to change it to the grade 11 one. And then I needed to check for difference of squares. So it's quite a complicated one, but just as the more you practice, the more it will come freely. Okay, example 3. So this is a step up because now I can't just work with one side. I don't have a clue which cos identity is going to help me get to the right-hand side the quickest. So in this case, I'm actually going to start with the right-hand side. Now, the reason I do that is because I only have one path to follow there. And maybe I get some of the other parts of this question, and then I know when I go to the left, which ones to choose. So right-hand side, I can see the left-hand side does not have a tan, so I'm going to change that to sine 2a over cos 2a. I'm going to then say divided by tan, but tan is also then sine a over cos a. Okay, so that's a very important tip. Because with tan, I only have one direction to follow. That's why I chose the right-hand side first, because now I can simplify a little bit. And I can actually see this cos 2a is already in the left-hand side, so I'm not going to have to change it. If I started on the left, I would change it, and then I would go so far from the actual path. So this is a very good thing now. So now I can change the sine 2a, so 2 sine a cos A. Like I said, this cos 2a at the bottom, I am just going to leave it like that because it is present in the left-hand side. Now I'm going to tip in times and say it's multiplied by cos a over sine a. This sine a's cancel out, and my right-hand side I can simplify to 2 cos squared a over cos 2a. Okay, perfect. Now I can have something to work with, because now I can go over to the left-hand side and try and get that to the same place. If I started this the other way around, I don't think I would have gotten to the answer. So, left-hand side, I can now, up top, I need to change that cos double. And a tip I want to give you guys is, if there's a random plus or minus 1, always choose the cos double. That would eliminate that plus or minus 1. So I want an extra minus 1 up top. So the option I'm going to choose is the one that says plus 2 cos squared a minus 1. And the bottom one, like I said, I am just going to leave it there. Okay, great. And there I actually have the answer. The 1 and the minus 1 cancels out. And 2 cos squared a over cos 2a. And therefore, left-hand side equals right-hand side. Okay, so it turned out not to be so bad because I started at the right point. Okay, so please practice a lot of them. I'm going to keep on saying this, practice a lot of them until it becomes second nature, which side to choose and which one to leave for a little bit later. So my tip, if there's too many cos doubles and you're not certain, check if you can change something else in the sum until you are certain which one. Okay, the fourth example. This is also an extremely important concept. If there are double angles and then quadruple angles, so 4a and 2a, don't change everything at once. Change them little by little. So I'm firstly going to change the 4a's into their double angles and see where I get to. So I know the right-hand side is sine over cos. So that already gives me a little tip, but I can't do much. Okay, so left-hand side definitely. Like I said, I'm going to change the 4a. So this will be 2 sine 2a cos 2a. Okay. And then minus sine 2a. So I'm not changing the second one. I want everything as 2a's at this stage. Okay, bottom is a bit trickier, but I don't want to introduce a new sign to the bottom. Everything is coses. I don't want to ruffle the feathers. So I'm going to choose the one that only has cos. So 2 cos squared, remember, it was half of 4, so 2a minus 1 plus cos 2a. Okay, up top, I need to factorize. I can take out sine 2a up top. I'm left with 2 cos 2a minus 1. At the bottom, that is actually a trinomial. So I'm just going to reshuffle to 2 cos squared 2a plus cos 2a minus 1. Now, for those of you who struggle to do trig and trinomials, you are quite normal. That is a very complicated concept to do mixed chapters and trinomials and trig and everything. So just make it x's for yourself. So this is just 2x squared plus x minus 1. In a bracket, that would be a 2x. That would be a x. This would be a 1 and a 1. I want a positive, so that's a plus, that's a minus. Okay, so you are allowed to do that in pencil on your page just to make life a little bit easier with this complicated chapter. So now I just need to rewrite the trinomial. So sine 2a, 2 cos 2a minus 1 stays the same. At the bottom, that would then just be cos 2a plus 1. And then the other one is the same bracket. So 2 cos 2a minus 1. They can cancel. And now, because the right-hand side only has a single a, I can just expand the double angle up top. So only one option, 2 sine a cos a. And at the bottom, once again, I'm going to choose the one that will eliminate the plus 1. And I don't want to introduce an extra sign at the bottom. So this would just be 2 cos squared a minus 1 plus 1. And therefore, the ones cancel out. So these two become 0. The squared cancels the cos, the 2 cancels the 2, and therefore left-hand side equals right-hand side. So that is really one of your more advanced ones. So let's just go over the steps again. I first changed the 4a's into their double angles. The reason I did that is because then I could factorize. So I did a common factor up top, I did trinomials at the bottom, then I canceled the brackets, and then only I changed the normal double angles and got to the answer. Don't do everything at once. You're going to go so far off track that you won't be able to get back. The next example, I am again going to have to do both sides in this case. So starting with the left-hand side. Okay, so why do I start with the left? Because tan only has one direction to go. I am avoiding the cos double until I know which option will help me the most. So this sum is all about primary school fractions and getting the LCD and tip and times. Okay, so let's see what I mean. So up top, I can say this is 1 plus sine a over cos a, all over 1 minus sine a over cos a. Okay, that looks horrible. I hate double or triple fractions. But anyway, I'm going to get over myself. Let's go. So I need to do a LCD up top. So that 1 I can multiply with cos over cos, and that would change it to cos A plus sine A all over cos A. Like I said, I absolutely hate triple fractions. So I am instead going to make the big fraction sign, I'm going to make a divide, and I'm going to also LCD the bottom. So that would be cos A minus sine A over cos A. Okay, now that it is one fraction divided by one fraction, I can tip in times, and then it would look like this. So after tip and timesing and cancelling, I can see that my final answer for the left-hand side is cos A plus sine A over cos A minus sine A. Now I have a clear direction of where I want to go on the right-hand side. So I need to tell them now I'm switching to the right-hand side. With the sine double angle, I only have one option there. So I'm going to say it's 1 plus 2 sine A cos A, and the bottom, so now if I look at the left-hand side, I want sine and cos. So I'm actually going to change this to cos squared A minus sine squared A. It still looks quite far from where I need to go. I can't just ignore the squares. And this is now also a very tricky one. Whenever you see a 1 in trig identities, always consider that in grade 11 we learned that 1 can be written as cos squared plus sine squared. I'm actually going to rewrite it as sine squared A plus cos squared A. Okay, so I cheated a little bit. I went back, but you can just rewrite that step. That now enables me to do a trinomial up top and difference of squares at the bottom. So, yeah, you thought factorization was gone because there's no chapter in grade 12 for factorization. Unfortunately not. They saved it for calculus and trig. So you can rewrite all of these as x's if you want to. That's 100% fine. But let's attempt it as trig. Okay, so up top, I have a trinomial. And it's really the easiest trinomial, but it looks horrible because of trig. So I know sine squared is just going to be sine A times sine A. And then cos squared is just cos A and cos A. Okay, the signs are all pluses, and that means the bracket has only pluses. The bottom is now difference of squares. So again, two brackets, and then this is cos A times cos A, bracket with a minus, bracket with a plus, and then sine A and sine A. Now I can just see the bracket with the plus is going to cancel out, one at the bottom, one at the top. Now remember, because it's a plus, I can change the order. I don't need to put a minus in front or anything else. So they are just gone. And look at it, it is now the right-hand side. So up top, I can rewrite it as cos A plus sine A, but it means absolutely the same thing. So therefore, left-hand side equals right-hand side. Okay, so why did I start with the left and not with the right? Because on the left, I only had one direction to go. Tan can only be written as sine over cos. So that was my safest bet so that I don't make a mistake. If I started with the right and I chose the wrong cos double identity, it would have been very difficult to get back to the other side. It's possible, but very complicated. So start with the side where you are sure that you chose the right one. I really pray and hope that you guys don't see this year, because quite honestly, it's one of the more horrible sums in grade 12 trig. Okay, so we did cover this in a previous video where we did the combined double angles and compound angles, but let's go for it again. In this case, I now need to choose, and I normally tell you guys choose the one that's the more complicated, that looks more complicated. In this case, please don't choose the left-hand side, because you're never going to get to a triple angle. You can't reverse engineer this to get to a triple angle. So always start with the triple angle if you get this one. Luckily, there's only two variations, cos triple angle or sine triple angle. They don't normally throw in other things as well. So let's go. I'm going to start with the right-hand side, definitely, with this. And I'm going to say this is cos 2a plus a. Okay, my compound angle says I can expand this into cos 2a cos a. Sine changes to a minus, sine 2a, and then sine a. Okay, I can see I want only coses in my answer, so it's easy to choose the correct cos double angle. So this would just be 2 cos squared a minus 1. Then outside the bracket is just the normal cos a. Sine double, I don't have an option. I need to just go for 2 sine a cos a, and there is another sine a that's just hanging around there. Now I need to multiply into the bracket, and that's going to be 2 cos cubed a minus cos a, and then that will be sine squared. And I know I can rewrite sine squared as 1 minus cos squared. So just going to highlight so you guys don't lose me. So these two, so I'm just going to say I know that sine squared a is equal to 1 minus cos squared a. So I'm going to put the 2 and the normal cos just together, And then that one I'm going to change to 1 minus cos squared a. Because now I just need to multiply 2 cos a into that bracket, and then hopefully I'm close to the answer. So 2 cos cubed a minus cos of a. So I'm just multiplying 2 cos a with 1, so that just stays 2 cos a, and then 2 cos cubed a. And there we go. I actually have their answer. Now I can see the cos cubed are the same, so that would just be 4 cos cubed a, and then minus 3 cos a, and wonderful. Now left-hand side equals right-hand side. Okay, so quite a few steps to remember with this thing. Yeah, please study it. It can come up, but like I said, I really hope you guys don't see this. So that's the end of the video. These were only a few identities. Your teachers can get very creative and come up with things, but the textbooks have great examples for this. So please try as many as you can. Try to understand them. I know it's a complicated thing, but it can be easy marks if you understand where to go, what to look for, and just follow the recipes. Great, guys. Good luck with this. I'll definitely make a practice video, and let's see how you go.
If this video helped you, please like and subscribe.
JMath.